Today we will learn commutative property of the following mathematical operations with respect to whole numbers. We know that all the numbers from 0 to infinity are called whole numbers. Commutative property allows a mathematical operation to be solved by changing the order of the numbers. Let's understand in detail. Let's talk about the addition of numbers. Can we add two whole numbers in any order? Think about it. Let's suppose we draw 3 circles on the left and 4 circles on the right on a piece of paper. On doing so, the total number of circles we get are 3 plus 4 is equal to 7. If we rotate the paper this way, then the order of the circles will change. By doing so, there will be 4 circles on the left side and 3 circles on the right. Is there any change in the total number of circles? No. The number of circles is the same as before, that is 7. Thus, the commutative property of addition tells us that there will be no change in the final number even if we change the order of the numbers, which means a plus b is equal to b plus a. So, whenever you wish to find the sum of two whole numbers, you can add them in any order. You will get the same result even on changing the order of the numbers. Just like addition, is the subtraction of whole numbers also commutative? Think for a while. Let's see. Is it possible to subtract a smaller whole number from a bigger whole number? However, we cannot subtract a bigger whole number from a smaller whole number. Therefore, the subtraction of any two whole numbers, a and b, cannot be done by changing the order of the numbers. That is, a minus b is not equal to b minus a. Therefore, subtraction is not commutative for whole numbers. Now, let's talk about multiplication. If we make two rows of 3 balls each, then the total number of balls can be obtained by multiplying 2 and 3. The product is 6. However, if we change the order by making 3 rows of 2 balls each, then do we get the total number of balls same as before? Yes, 3 times 2 is also 6. This shows that multiplying two whole numbers in any order will result in the same product. Therefore, for any two whole numbers, a and b, the product of a and b is equal to the product of b and a. Thus, we can say that the multiplication of whole numbers is commutative. Coming to division operation, the division of any two whole numbers a and b cannot be done by changing the order because a divided by b is not equal to b divided by a. For example, 4 divided by 2 is equal to 2. However, 2 divided by 4 is equal to half. Therefore, 4 divided by 2 cannot be written as 2 divided by 4 by changing the order. Therefore, division of whole numbers is not commutative. Today we learned that addition and multiplication of whole numbers are commutative, whereas subtraction and division of whole numbers are not commutative. In the next video, we shall deal with a few examples related to this property. Today we will see a few examples of commutative property of addition and multiplication of whole numbers. Rajesh keeps 3 apples in a basket and after some time he keeps 2 oranges in the same basket. If Rajesh keeps 2 oranges in the basket first and 3 apples later, does that change the total number of fruits? Can we apply commutative property here? Case 1. Keeping 3 apples first and then 2 oranges in the basket. total number of fruits equal to number of apples plus number of oranges, which is 3 plus 2, that is 5. Case 2. Keeping 2 oranges first and later 3 apples in the basket. Total number of fruits equal to number of oranges plus number of apples, which is 2 plus 3, that is 5. In both cases, there will be 5 fruits in the basket, which states that 3 plus 2 equal to 2 plus 3, or in other words, number of apples plus number of oranges equal to number of oranges plus number of apples. This example shows the commutative property of addition of whole numbers. Next example. There are 2 cupboards. There are 5 rows in first cupboard and in each row only 3 cups can be arranged. In the second cupboard, there are 3 rows and in each row only 5 cups can be arranged. Can you tell which cupboard will have the maximum number of cups? In the first cupboard, there are 5 rows and in each row only 3 cups can be arranged. So here you can arrange a total of 5 into 3 cups. Now, think about the second cupboard. Here the arrangement is a bit different. Here, there are 3 rows in which 5 cups can be arranged in each row. So a total of 3 into 5 cups can be arranged in the second cupboard. Since multiplication of whole numbers is commutative, either we do 3 into 5 or 5 into 3. The answer will be 15. This shows that 15 cups can be arranged in both the cupboards. Next example. Fill in the blanks. Since addition of whole numbers is commutative, we will write 2 in the blank. Since multiplication of whole numbers is also commutative, we will write 7 in the blank. Today we saw a few examples based on commutative property of addition and multiplication of whole numbers. In the next video, we will see few misconceptions related to this property. Today we will see misconceptions and common mistakes related to commutative property of addition, subtraction, multiplication and division of whole numbers. Misconception 1. Teacher asked a question in the class. Is the subtraction of 77 and 33 commutative? Sarah answered, yes, while Roshan said no as an answer. Who gave the right answer? 77 minus 33 is equal to 44. Students also start thinking that 33 minus 77 is also equal to 44. With this misconception, students think that the subtraction of whole numbers is also commutative. With the same understanding, students think Sarah's reply is the correct answer and they choose option 1 as the right answer. This is an incorrect answer. The correct understanding is that 77 minus 33 is equal to 44. However, 33 minus 77 is not equal to 44. In fact, the result is a negative number, minus 44. We will learn about the negative numbers in the upcoming chapter. Since the result of 77 minus 33 is not equal to 33 minus 77, the subtraction of 77 and 33 is not commutative. With this understanding, Roshan has given the correct answer. Misconception 2. Is 6 divided by 3 equal to 3 divided by 6? It is a common misunderstanding that, just like addition and multiplication, division is also commutative. With this misunderstanding, incorrect answer yes is chosen. To find the correct answer, we must compare the results of 6 divided by 3 and 3 divided by 6. Let's find the result of 6 divided by 3. Suppose you have 6 lemons. If you wish to make 3 equal parts, then each part will consist of 2 lemons. So, The result of 6 divided by 3 will be 2. Now let's find the result of 3 divided by 6. If you have 3 lemons and if you wish to divide them into 6 equal parts, then how can you do this? Think for a while. You must cut each lemon in half to make 6 equal parts. Since each part has half lemon, therefore, the result of 3 divided by 6 is half, that is 0.5. Now if we compare the results of the two, then it can be understood that the values of 6 divided by 3 and 3 divided by 6 are not equal. Now let's understand some of the common mistakes related to commutative property. Often students know the commutative property. However, they don't use it for simplifying the addition or multiplication. For example, the addition of 3 and 9 is done in the given order, whereas it is difficult to add a larger number to a smaller number. However, by changing the order, the result of addition can be obtained very easily. Similarly, multiplication of two numbers like 3 and 9 is also done in the given order, which appears difficult. But if we change the order, then the same multiplication turns out to be simple. Therefore, it is very important to have a better understanding of the commutative property. Today we saw misconceptions and common mistakes related to commutative property of addition, subtraction, multiplication and division of whole numbers.